Well, good afternoon, everybody. I am actually going to give a presentation on the nuclear structure of odd mass 117 antimony nuclei. Now, as you can already see, antimony nuclei is basically a medium mass nuclei, okay, and it's having a proton number of 51, and well, the corresponding neutron number is 170 minus 51, that is around 66. Okay, so this nuclei basically lies in this transitional region, and as you know from my previous video slide that these nuclei actually have their own specific properties. Now, well, going into this, uh, now, if as we go to the next slide, we would see that there are some basic features of the band structure of the protons and neutrons that lie within the nuclei. This band structure arises from the specific configuration of the protons within the Nielsen state. Now, I would basically focus on a strongly coupled band which is based on a G9 proton hole state. Now, these bands arise because of the excitation of a proton from below the Z equal to 50 shell gap. Now, now, one of the most important characteristic of this band is the band has strong E2 transitions corroborated by weak crossover M1 transitions. Now, when we look into the Now, when we look into the structure of these nuclei deeply, we try to probe into the reason why this band looks so different, the physics of this band structure. Two important factors plays a significant role in developing the physics of the band structure. One is the Coriolis coupling, the coupling between the odd particle and the corresponding even core, and the corresponding attenuation factor. The Coriolis coupling between the odd proton and the corresponding even tin core actually is very strong. It is quite high in building up this strongly coupled band structure. Okay, kotha bolo. And the attenuation factor for this band structure is supposed to be minimum or zero. আমি রেকর্ডিং করছি তো একটু বলে দাও. Now, the other features of the band is this band can be extended to reasonably high spin, and after a certain spin value it may attain band termination. Now, the band termination means that at that particular spin value the band gets terminated, and it has been observed that many of the levels within the band have quite high value. They have quite a high value of the order of the lifetime of these states are quite high, of the order of few nanoseconds. Now, these are some of the salient features of this strongly coupled band. The band head actually occurs at reasonably low energy, and the important thing about this band is that this band extends up to a fairly high spin. So, apart from this, there are many other salient features which we would be discussing in the forthcoming slides.